So the last unit we'll be working on this semester is based on Chapter 1, and Chapter 1 is logical reasoning. So we're going to start with the first section today. And the important thing to know about Chapter 1 is that it's really just it's more logic than pure math. So this is going to be a lot of thinking, and if you're not already doing it when you watch the videos, try participating, try thinking about these things, because this is sort of what the test will be like. We'll be making these thought processes and writing them down. So section 1.1 is making conjectures, and this is what we call inductive reasoning. So first of all, to define what those are, because a lot of people have not seen those words before. So a conjecture is an unproven conclusion, but it's based on evidence. So it's not just you saying something for no reason. You've seen the evidence, and then you make a conjecture. So my conjecture could be, the ground outside was wet when I woke up this morning, so it rained. Okay, now I don't know for sure it rained because I wasn't up all night, but the evidence, being water all over the ground, means that it probably rained. Now, I don't know, maybe the street cleaners came and they cleaned all the streets and that was why they were wet. But a conjecture is something you see some evidence and you think, well, this is what I think happened, so you make a conjecture. And inductive reasoning is the process of making general conjectures by looking for patterns. And when you look for a pattern, you identify a certain property. And so we use inductive reasoning in specific examples. And then using those specific examples, we make a general rule. So in inductive reasoning, we start small and go big. Okay, so you look at, say you have 3 pieces of evidence, and then you make this sweeping conclusion about everything. So things like this. So in this first example, when we look at these figures, so figure 1 has 1 circle, figure 2 has 3 circles arranged in a triangle, figure 3 has 6 circles arranged in a triangle. So what conjectures can we make about what the 4th figure would look like and the 10th figure? And then we can go up from there if we wanted. So first of all, we should make observations. And if you make your observations thorough enough, a lot of the times your observations can just become your conjecture. So when I look for observations, I think, okay, well, as they move up from 1 to 2 to 3, each triangle has 1 row more than the last. Okay, and so this unit will involve a little bit more writing than you're used to, but just take your time, think about your observations, and try to make them as thorough as possible. And then always try to make more than 1 observation. So I noticed that figure 1, the bottom row has 1 circle. Figure 2, the bottom row has 2 circles. And figure 3, the bottom row has 3 circles. So the bottom row of each figure has the same number of circles as the figure number. Now again, we only see 3. And so this is why when we make our conjectures, we're basing the evidence on these 3 things. But we don't know for sure. So it's just, this is our evidence that we're working with, and so this is all we can base it off of. So here, I think that the pattern is that each new triangle or each new figure has a new row of circles on the bottom with 1 more circle than the row before. And the wording in your conjectures, everyone's will be different, and that's okay. And if you feel not confident in your wording, just be sure to use lots of examples. So write out your sentence and think, well, maybe that's not clear, and then say, example, figure 2 has 2 in the bottom, figure 3 has 3 in the bottom. So just sort of try to prove what you're saying and prove what you're seeing that. So in the fourth figure, if I'm looking at the fourth figure, and I drew it the same, I would think that it would look something like this. And then I would put 4 on the bottom, and that would be my next figure. So in that case, I would think in the fourth figure there would be 4 rows of circles. Okay, so 1, 2, 3, 4. They're arranged in a pyramid or a triangle like the other ones were. And the fourth row would have 4 circles in it. And that's based on my conjecture. So if you had a different conjecture, then you might think there are different numbers of rows. And then in the 10th figure, based on my conjecture, I would think that there'd be 10 rows of circles arranged in a pyramid, and the 10th row would have 10 circles in it. Okay, so you'll see that conjectures are a little bit more flexible than the rest of the math we've been seeing, because as long as you can show evidence for your conjecture, you can have different conjectures from other people in the class. Okay, so then I look at the next example. 1 plus 3 is 4, 3 plus 5 is 8, 5 plus 7 is 12, 7 plus 9 is 16. And so just make sure you're looking very carefully at all this stuff, okay? So if I look at first the things that are being added, then they're called add-ins. So I have 1 plus 3, 3 plus 5, 5 plus 7, 7 plus 9. So I noticed that those are all odd, and so I'll call them add-ins, and those are the numbers being added. So they're odd, right? 1, 3, 5, 7, 9 are all odd. And then when they're being added with their consecutive odd number. So the number that's right after it. So when you count up by odd numbers, you go 1, 3, 5, 7, 9, 11, 13, etc. So here you'll have 1 plus 3, 3 plus 5, 5 plus 7, 7 plus 9. So they are consecutive odd numbers. And again, if you don't know the word consecutive, or you're not sure of which correct math word you should be using, write it out in simple terms and then just show me an example to tell me what you mean. Then let's look at the sum of each pair. So we have 4, 8, 12, 16. So those are all, so the sums are all even. Okay, so that's one observation. Let's see if we can get one more observation out of this. And we'll look at the sums again. So let's write them out here. 4, 8, 12, 16. What do you notice about all those? So when I look at those, I think those are all multiples of 4. So each sum is a multiple of 4. Okay, so then we'll put all our observations together, and that's why it's nice to get as many observations as you can, because then your conjecture can be quite thorough. And if you spend time on your observations, writing your conjecture should be quite easy. So I'm going to put all those things together and say that the pattern is the sum of consecutive odd numbers is a multiple of 4. And then our next step, when we make a conjecture, then we have to look for further evidence to support it. So to do this, what you would do is add other pairs of consecutive odd numbers, and then see is the sum, or each sum, a multiple of 4. So I'm going to get you to do that, and then on Tuesday after the test we will talk about this, and go really big. So try like smaller numbers again. You might try 9 and 11, or 13 and 15, or 21 and 23, but then try very large numbers and see if it keeps working. And try 4 or 5 pieces of evidence. So make sure you do your review for Chapter 8. Print off the bonus quiz for Chapter 8. There will be no homework for this Chapter 1 part, and we'll continue it on on Tuesday. Again, email me if you have any questions, or come see me Monday before the test. And otherwise, I will see you Tuesday morning. Have a great weekend.